Welcome to our remote biomechanics teaching studio. Hey, today we're going to talk a little bit about running shoes, some of the physics behind it, some testing. I'll go through some different examples of shoes. And what we need to do in this class is think how biomechanics applies to designing running shoes, as well as maybe when you need to purchase a pair of running shoes. So let's define what a shoe is first of all. A shoe, if you look up in the dictionary, is any type of covering of the foot. Very broad sort of definition of what a shoe is. When we think about a running shoe, we think a little bit more in terms of all the different parts of a running shoe. However, there is no real minimum number of parts or maximum number of parts that a shoe can have. And lots of shoes are different simply because they add different parts or they manipulate different parts. So a minimalist shoe, you probably have heard that phrase, is something that just really is using the minimum amount of material to cover the foot and maybe protect it from scrapes or from scraping your toe on a rock, or maybe just protecting it from the heat of the pavement. That may be something that's as simple as a thin sole and some type of upper or something that attaches that sole to the foot. And there's a lot of neat research on minimalist type shoes. And on the other end of the spectrum, and I'll show you these shoes in a bit, is maximum cushioning shoes. It's really not maximum, but it's extreme cushioning, or it's cushioning that is far more than what we would see in a minimalist type of shoe. So let's go through some examples. I'll go through a little bit of anatomy, but realize that a shoe really would minimally need to consist of some type of sole to cover the bottom of the foot and some type of upper that connects or holds that sole onto the foot, and everything else is sort of extra in terms of shoe parts. So I'll give you an example. Here's a pair of shoe, or here's a shoe. All right, and you'll see how the front part of the shoe is cut off and the back part. Oh, why did I do this? When I did this, and I did this because, one, it was an old pair of shoes. They were pretty worn out. You can even see some of the wear on the sole here. And I needed or wanted a more comfortable sandal. So I just cut off the parts of the shoe that weren't really necessary. I wasn't really going to run in these shoes, more just walk. But I ended up using these shoes for the transition section of a triathlon. Very common. What I'll do is on races that have a long transition, or the road to run on from the water to my bike is a rough road. I'm old, my feet are a little sensitive. I'll go stick a pair of these at the end of the swim where you get out, the swim exit. And then I'll just take a second to slip these on, and then I'll run in these to my bike, and then take them off and put my bike shoes on. So they actually turned into a nice functional shoe for a triathlon. And you may say, well, what if someone takes your shoe? Well, I don't really care, because this shoe is pretty useless anyhow. So if I got out of the swim and someone had taken it or moved it, I really wouldn't worry too much about it. Wouldn't lose sleep over it, because these are pretty much throwaway type shoes anyhow. But just to emphasize that a shoe could be something quite different than what we would think as an entire shoe. So different parts of a shoe. This is the outer sole. This is the midsole, this whole part here that you see. And this would be the insole. Okay? Insole, midsole, outer sole. All right? And these vary in design between manufacturers and models. This is more of a maximum cushioning shoe or an extreme cushioning shoe category, because this has a big heel or lots of material here. The height of this would be referred to as the stack height of a shoe. So stack height. Stack height determines how high the heel is, how much cushioning there is here. Another term that's really important in terms of describing the thickness of this midsole would be the heel to drop height. So we would calculate or measure this height, then we would measure this height, and then we would calculate a difference. And that difference would represent how much of an angle the foot would be in about the ankle joint when standing still in the pair of shoes. So clearly the higher the stack height or the lower the front part of the shoe is, the bigger that drop of the shoe is. Some people really need to pay attention to drop height of the shoe because it may stress or unstress the Achilles depending on which way you're going. And some people with Achilles injuries or people who may be sensitive to Achilles pain may want to try different shoes of different drops. But when you're buying a shoe, you typically want to look at the drop height or the heel to toe height. So the stack height is just how much is in the heel region, and the drop height would be the difference between the front and the back part of the shoe. This is the upper, and the uppers can be of all different material. These are all the different eyes of the shoe. This is the tongue of the shoe, and they're all built a little bit differently. Obviously, the laces are important when we're looking at shoes. If you're in triathlon, often people will use laces are very elastic to allow for easy putting of the shoe on, because that will stretch and the foot can fit in the shoe. But some people don't like an elastic lace because you can have a bit more shoe movement during running. And sometimes you want to have more of a stiffer lace so it holds the upper in place on the foot and therefore the sole of the shoe. Okay, so this is an odd pair of shoes. Let me show you a couple of others. This is a little different shoe. This is a zero drop shoe, which means the heel and the forefoot are of the same thickness. So no drop. That's an interesting shoe to try to get used to if you're not used to running with a drop. Shoe that I just showed you probably had, I think it was about a 4 millimeter drop. Doesn't seem like a lot, but those shoes can range from 4 to 10 millimeter drop. So 10 millimeters is a centimeter, so about the thickness of your finger. That can actually be quite a bit, and your body will sense that change in drop. But sometimes people like a zero drop shoe, and sometimes people don't. You have to try it out. This shoe, since I haven't cut it up, this has a heel cup, all right, to provide a bit of stability to the subtalar joint, all right. These shoes also have a wide toe box, all right, a wide toe box. The Altras are known for that toe box, very comfortable on the toes. And one of the common injuries runners have is black toenail. And part of the black toenail is due to too tight of a toe box. So you want to watch for that. Inside the shoe, there's also arch support. You're getting like an arch cookie that supports the arch. There's actually a lot of debate as to whether or not this is a good thing or a bad thing. On one hand, you want the body to perform the way that it's built, and the arch does serve a function of running. When you're running or walking, that the arch of the foot will collapse and absorb some of that impact during running. So there's often a debate on whether or not having shoes provide that arch support is a good thing. All right. Now, we don't know. We do know that runners are very susceptible to overuse injuries, and typically anywhere from 25 to 75% of runners will get injured while training for a marathon. That's a high rate of injury. So despite all the shoe technology that has changed over the last 40, 50 years, runners are still getting hurt. So we still don't know the exact way to keep people from getting hurt. All right, so that's a different design. This is an Ultra zero drop, wider toe box, another part of the shoe that we described, and then a heel cup that provides support to the subtalar joint and either allows for good movement of the subtalar joint, so allows for pronation, or limits pronation. Again, big debate as to whether or not you want a shoe to limit some of the ways that the foot wants to move. Oh, this is a weird shoe. This one's a little different. I see that part right there. Well, now you can see the name of the shoe, AQX, has something to do with aquatics. These are shoes made for running in the water. And these little cups here will catch some of the water and provide some increased drag to moving the foot through the water when you're trying to pull the foot backwards. So these were designed in large part for deep water running. It's also designed for shallow water running in that you have a sole that will grip the bottom of the pool better than a typical sole. So this material here allows for a little bit more friction of a pool surface than a normal shoe. And that's something you can test on a shoe, is how much friction it allows. That friction force would prevent the foot from slipping on the surface. Okay, if the foot's not moving, then the friction force is sufficient to prevent the shoe and the foot from moving forward. If the friction force is not enough, the foot will slip and you may fall. So running on ice is different than running on pavement. All right, so just a little different design and just sort of fun to look at some unique type of shoes. Give you another one. This is another brand of shoe, more in the extreme cushioning shoe. This one's more of a racing flat, so it's a very light upper material. Now you can see the quick tie for triathlon. We're not taking time to tie your races. These laces, these don't have much flexibility. So you would stretch the tongue out, get your foot in there, and then pull this tight to hold the upper to the foot. These different shoes will advertise different parts that are added to the shoe that are unique. Hoka is known for including a meta rocker. That meta rocker is at the metatarsal joint, where it is designed to help, the claim, designed to help in propulsion of the foot. So remember, when we're using a shoe, we strike the ground most likely with the heel, usually the outer part of the heel as well, and then roll forward. So this part of the shoe is going to work to absorb the impact energy, attenuate the impact force, and then you're propelling with the foot in this position. And so it's really quite a tricky research or tricky design of a shoe to allow for absorbing impact energy, attenuating impact forces, and then transferring that energy to propulsion. It's not necessarily an easy thing to do. All right, let me pull up another pair of shoes here. This is just a pair, same brand. This is a little thicker stack height, so a thicker heel, and it has a little bit more drop between the heel and the toe thickness. Let's look at wear and tear of a shoe. I guess I should have brought up a brand new shoe, but we can start looking at a shoe and how much wear is happening by inspecting the sole. And you can see how, hopefully you can see, this part's really smooth versus everywhere else on the shoe is a little bit more rough. Well, this part has just gotten worn down. So one thing that we can tell from this shoe is that the runner, in this case it's me, strikes the ground with this part of the shoe. All right, and that's pretty common to hit the ground, usually with the lateral aspect of the rear portion of the shoe. Now, when we start talking about foot strike patterns, we'll typically talk about anyone who hits the ground first with the shoe in the last third would be a heel striker. Anyone who hits the ground first with the front third of the shoe would be a forefoot striker. And then a midfoot striker would be anyone who hits the ground first in the middle third of the shoe. Probably 80–90% of us are heel strikers. You can talk about the benefits or the risks of changing foot strike pattern. That's another great topic to either research or to talk about. But yeah, the key is you've got to figure out what type of strike you have, and then make sure you pick a shoe that matches that. So if you're not a heel striker, this probably isn't the right shoe for you. You need a shoe that has more. If you're striking more with the forefoot, you need shoes with more cushioning up in the front region. Okay, so now I just want to show you another uh, something that's related to shoes is shoe testing, where we look at how much impact energy a shoe will absorb. That's really one of the key features of a running shoe, especially when we're looking at distance running. If we're talking about sprinting, totally different situation. Sprinters sacrifice shock absorption of the shoe for performance to being able to provide a propelling force. So let me just show you a picture of a shoe testing device, which we have in our lab. That's not it. Try to bring this picture over. Okay, hopefully you can see this picture and I'm doing it right. This is a shoe testing device. We put the shoe down in this region of this machine, and then we have this impact tester with a known mass up here. And this machine here raises up this mass and then drops it onto the shoe. This whole mass is connected to this channel here, or this rod here. So this gets picked up about 50 millimeters and then gets dropped on the shoe. So it gets picked up about half a centimeter and then dropped. And then this has this column here has instruments in it right here, a force transducer to figure out how much force is happening during this impact. And by knowing how force is being applied to the shoe over time, we can figure out how much impact energy there is. And when we know the drop height of this missile, we know how much energy the shoe or that impacts the shoe by 1/2 mv squared. And then we can figure out how much energy is absorbed by knowing how long it takes to stop the missile from moving downwards. And this instrument in here allows us to measure all that. So this is a nice way to test out the mechanical characteristics of a shoe. And we do this quite often in our lab, and we have this equipment in our lab. And major manufacturers of shoes or designers of shoes will have the same type of equipment. All right, stop sharing. All right, so we would do often, if we're working with a shoe company, we would do a impact test of the shoe, and we'd be able to determine some of the mechanical characteristics of the shoe. And then we would also do a test of the shoe by having people run in the shoes over our force platforms. And that's where things can get a little hairy, because one of the things that's really important to know is the way somebody runs will influence how a shoe performs. I've already mentioned forefoot and heel foot strikers. That is, if you hit the first part or hit the ground with the forefoot part of your shoe versus the rear foot. Those are quite different running styles, and those two running styles demand different types of shoes. Well, all of us have subtly different types of running styles. I hit with the lateral aspect of my heel. Some of you may hit a little bit more anterior to what I hit, or maybe you hit a little bit more medial to where I hit. All of those different running styles will influence the choice of shoe that anyone will want or need. And same thing in terms of the amount of control or amount of resistance a shoe provides to movements, from the arch height, the arch cookie, arch support, to the heel cup. The amount of restriction that one may want is going to be dependent on how much movement someone has at the subtalar and the ankle joints, or how much movements they want to minimize. In general, it's probably good to start with a shoe that really influences, excuse me, that minimally influences the movements that would normally occur around the foot ankle complex. And then you go from there. How do you know you've got a good shoe? Well, unfortunately, it's a lot of trial and error. And you know you've got a good shoe if you're not having any running related overuse injuries. That's a terrible, terrible metric, but that's what we fall back on. If you're not injured, you're probably in the right pair of shoes. And if you are having injuries, whether that be at the foot ankle or whether that be at the IT band or even at the hip, that's a time to start looking at different shoes. And I also talk with people about making sure they change their shoes out well before they're worn. For example, I showed you the worn heel on this shoe. What happens when this heel gets worn like this, I start changing the way that I run because I have a different type of shoe because that heel's worn down. But then if I buy a brand new pair of shoes and this heel is not worn down, then I'm going to potentially run into a problem because now I'm using a running style that's built for one type of shoe or shoe wearer, and then applying that running style to a brand new pair of shoes, and that may actually require a different type of running style. So we got to be careful about picking shoes. We got to be careful about switching out shoes before they're overly worn. So we often rotate shoes around to have even wear on the shoes. And then we got to pick shoes based upon our running style. Okay, I hope this was helpful in talking about the biomechanics of running shoes.